Okay, we are finding zeros again, and we are using any way that we can to find the zeros of this function. So first thing we want to do is we want to look and say this is a fourth degree polynomial, 5x to the fourth. So we're going to have 4 zeros that we're looking for. Easiest way to get that first zero is to graph it. So we're going to go over to a graph, and we're going to put this in. So we have a 5x to the, let's see here, to the fourth minus 19x cubed plus x squared plus 31x plus 6. Okay, so I put that graph in and I can zoom out so I can see the entire graph, but I'm really just interested in the zeros, which are my x-intercepts. So if I look at the x-intercepts, they're pretty clear on here for me. I have a -1, then I have a -0.2, then I have a 2, and I have a 3. So I have some really nice zeros there. And we do want to get the exact fraction for -0.2, which would be -1/5. If we did it just like that, we could just put the answers in. But we're going to go through the process of getting all these zeros. So let's just make a note. We have rational zeros of -1, 2, and 3. Now, of course, this is also rational. It's just a little harder to find. So we're going to keep a note of that, and we're going to come back here. So we're just going to go left to right. So the first one on the left was a -1, and I'm just going to put the note over here. I had a -1, a 2, and a 3. Okay, now I'm going to use the -1 and synthetic division to reduce this to a third degree polynomial. So I take the -1 and all my coefficients, and I don't need to replace any because I go 4, 3, 2, 1. So 5, -19, 1, 31, and 6. All right, so we'll do synthetic division here. We bring down the 5. We do 5 times -1, which gives us a -5. -19 minus 5 gives us -24. -24 times -1 is +24. 1 plus 24 is 25. 25 times -1, -25. 31 minus 25 is 6. And 6 times -1, -6. So we get a 0 there. And we have reduced this now to a third degree polynomial. So 5x cubed minus 24x squared plus 25x plus 6. Okay, so we've got the -1 divided out. Now we need to get this to a second degree. So your goal is always to reduce until we get to a second degree polynomial, because once we do that, we have a quadratic. Quadratics are easy. So I'm going to go to the 2 now, and I'm going to divide this out. And when I divide it out, I'm not going to divide out from the top. I'm going to divide out from the third degree polynomial. So what I have here. So I have a 5, I have a -24, I have a 25, and a 6. Okay, so I bring down the 5. I have 5 times 2 is 10. -24 plus 10 gives us -14. And then -14 times -2 is -28. I have 25 minus 28, -3. And then we have -3 times 2, -6. These cancel out, so now I have a 5x squared minus 14x minus 3. Now I have a quadratic, so I can actually factor this, and it's really easy to factor. But we're going to actually keep going along this synthetic division route here. So now I'm going to take the 3 that I have, and I'm going to divide this out synthetically. So we're going to go here, we're going to go a 3, and we're going to go from the x squared. So we have 5, we have -14, and we have -3. So we're going to divide that out. So bring down the 5. 5 times 3 is 15. -14 plus 15 is 1. And 1 times 3 is 3. And those cancel. So now you just have 5x plus 1. I got the x because I went from x squared to x. So then for my final 0, I can just take this and set it equal to 0 and then solve. I can say subtract 1. I have 5x equals -1. Divide by 5, and I get a -1/5. So my 4 zeros are -1, 2, 3, and negative 1/5. Now I was able to do it this way because these are all rational zeros. Okay, so if I got to the quadratic and I can't factor at that point, then I would want to use the quadratic formula. So to see that, look at the previous video that just says, I think it just says finding zeros. This is going to be finding zeros when they are all rational. So a couple different ways you can go about doing this problem, but all pretty much similar, where we're going to graph, we're going to find the rational ones, divide out synthetically until we get to a quadratic.